Next, peoples, we're going to discuss about the next title. It is operating characteristics. Okay, let's go. It is nothing but this characteristics depend on the open circuit, which is nothing but a no load, and the short circuit characteristics. So, just consider about the no load characteristics. In no load characteristics, we need a main parameter. It is nothing but I naught. That means no load current. Under no load condition, the current value of that particular machine is nothing but I naught. That I naught has, we already know this, that I naught has a two component. One component is going to produce the flux, another component is going to produce the losses. It will be mentioned on this two way, which means of magnetizing current and the loss component of the current. The magnetizing current is defined by Im or I mu, that will be lag of 90 degree behind the voltage. Then the loss component, it is declared here as IL. In previous title we declared this as a IW. We also call this title as a working current. Now it is IL, which means of loss component. This current is going to produce the losses. It is in phase to the voltage. With this basic description, go with the declaration that I naught is nothing but the root of square value of Im plus IL. By this root square summation, we can predict the I naught value. With this content, we can also calculate the power factor value. That power factor cos phi naught is defined by losses current divided by no load current. With the content, we can also calculate the angle, no load angle, phi naught by making the cos inverse, and it will be declared as a tan phi naught is equal to Im divided by IL. So this is the basic expressions which is comes for determining the I naught value. Then that I naught, this is the graphical representation to declare about that particular I naught component, which is nothing but the combination of two things, IL and Im. So with this content, in the designing aspect, we have a lot of assumptions here. The approximation value of no load current expression in terms of full load current. Based on the full load value, it will be related. The output power will shows on the first column. A second column is nothing but the no load current percentage of full load current. Something in the full load value, it will be a range of this thing. For example, the first data for the 0.75 kilowatt, a 50 percentage of no load current is there from the full load. By this content, we have to assume the no load current value. So this is the one part, and no load current has been completed. And next one, in this area, we had two titles, a losses and a magnetizing current. Just see one by one. Now go with the magnetizing current. To calculate this magnetizing current, it is nothing but Im. To calculate this value, this is we has to consider about the flux. That means this is the current which is going to produce the flux. That flux in terms of flux density and H, it is should be in terms of mmf. So we can directly relate this thing. This current is found out by directly linking the mmf value of a different portions. So this is the thing. A path of magnetic circuit consists of a following parts. That means a magnetizing current is calculated by finding the mmf on air gap, mmf on stator teeth, mmf on rotor teeth, mmf on stator core, as well as mmf on rotor core. Just see one by one. So go for the first one. The thing is simple. We're going to find the 5 mmf value on different location of induction motor. After calculating this mmf value, after clubbing all this thing, we can easily find the total mmf. With this total mmf, we can easily find the magnetizing current. So go one by one. The first one, mmf in the air gap. Here a lot of assumptions is taking in the concern. So in the air gap mmf, we discussed this content in a very first unit. ATG is equal to 8 lakhs of BG value, which means of air gap flux density. But here it is nothing but BG60. Here it is declared BG60. That value is related by a plot. In that plot, to get the flat value of flux density, they can go with the 60 degree of angle. On this consideration only, they can plot on this content, which means of BG 60, and a kg is nothing but gap contraction factor, and LG is nothing but air gap length. So the descriptions are given below. BG 60 is nothing but the flux density at 60 degree from the interpole axis. Why the 60 degree is nothing but a constant value which is making to create the flat values. So that is the thing here. So this is the equation to finding the air gap MF value. It's a simple one, finding of air gap value. We go for the next one. MMF of the stator teeth. It is declared as AT suffix TS. It is nothing but product of two things, ATTS into DSS. Here the first one, ATTS, is nothing but MMF per unit length in ampere turns per meter. That value is calculated by the BH value of the flux density, BH curve of the flux density. In some problems we need to draw the curve and predict the ATTS value, or else it will be declared as a constant. Then next one, that constant value is found out by BTTS 60 is equal to 1.36 into BTTS 1 by 3, 1 third of value. So this is the thing, 1.36 is nothing but the constant. It will be with the product of BT 1 by 3. Now we're going to find the formula for BT 1 by 3. So the BTS 1 by 3 is equal to 5 divided by SS by P, which means of stator slots by pole, into Li, which is nothing but net iron length, into WTS 1 by 3. So WTS is nothing but width of the stator teeth. So yeah, that data is mentioned here. The WTS 1 by 3 is nothing but width of the stator at 1 by 3 height with a narrow end. These all the things are assumption which is taking for proper calculation of MMF. For this content, to calculate about WTS 1 by 3, yeah, one more formula is there, which means of pi multiply of d plus 2 DSS divided by 3. Here the DSS is nothing but depth of the stator slots, and divided by SS is nothing but number of stator slots, minus of WSS is nothing but width of the stator slot. DSS is nothing but depth of the stator slot. That's all for the content. So this is the equation to finding the value of MMF of the stator teeth. So after that, we enter to the third one, which is nothing but MMF for the rotor teeth, ATTR. It is calculated by the product of two things, the same thing, ATTR into DTR. Here the DTR is nothing but at same thing, depth of the rotor teeth, and the ATTR is nothing but calculating by the BH curve. Its constant is related by BTTR 60 is equal to 1.36 BTTR of 1 by third value. So BTTR 1 by third value is defined by 5 divided by SR by P into Li into WTTR of 1 by 3. So again WTR of 1 by 3 is calculated by a separate equation, which is nothing but pi of dr minus of 4d SR divided by 3 whole divided by SR, then minus of WSR. This expressions is taken as a constant, then no need of derive all this thing. Consider this equations one by one to find the MMF value of the rotor teeth. It's a third one. Then go with the fourth one, which is nothing but MMF of the stator core. Now we enter to the core areas. In that location, the core area is defined as C. So 80 for the stator, it is mentioned as S, ATCS. It is nothing but the same thing, product of ATTS into LCS. Here the LCS is nothing but the length of the flux path through stator core. So the LCS value is there to find. So pi 2 into DSS plus DCS divided by 3P. So DCS is nothing but depth of the stator core. DSS is nothing but the depth of the stator slots. So that's all for the content. P is nothing but the pole. Capital D is nothing but the overall diameter. With this concern, we can calculate all this thing. Then a fifth one is nothing but MMF for the rotor core, which is nothing but ATCR value. So for the capital ATCR is nothing but small ATCR into LCR. So the LCR value is nothing but length of the flux path in rotor core. So we had a formula here, pi into dr minus 2 dsr minus dcr divided by 3p. Then here the same thing, dcr is nothing but depth of the rotor core, dsr is nothing but depth of the rotor slots. So that's all for the content. We had a 5 formula here. Peoples, listen here, just concentrate on the formulas. This is nothing but the simple one. To calculate about the magnetizing current, we need to calibrate the 5 mmf value. That 5 mmf is on this thing. Yeah, see this content. This is nothing but the total mmf produced by the value at the flux at 60 degree. On it is nothing but 80/60. It is calculated by the 5 value of mmf. One is nothing but air gap mmf 80g. Another one is nothing but stator teeth mmf, that is nothing but 80 suffix ts. Then next one is nothing but rotor teeth mmf, that is nothing but 80 tr. Then next one is nothing but a stator core mmf, so 80 cs. The next one is nothing but rotor core mmf 80 cr. So we already discussed the 5 titles in previous content. We had a 5 formulas here to calculate all the mmf value. After calculate all this thing, club produce the club all the thing and find the summation values, that is nothing but 80/60. After find this 80/60, go for the final formula. Im magnetizing current per phase is equal to 0.427 of P into 80/60 divided by kWs into TS. Here the TS is nothing but number of stator turns and kWs is nothing but winding factor. Then P is nothing but pole. 0.427 is nothing but the constant. Then 80/60 is nothing but a total magnetizing mmf per pole for the value of flux density at 60 degree. So this is the final content, peoples. Once you declare this all the content, you can easily calculate the mmf value. By calculating the mmf, you can easily find the magnetizing current. So that's all for this. Then after calculating the magnetizing current, one more another data is there in I naught. I naught is nothing but the two now. One is magnetizing current, another one is nothing but a loss component. Go for this content. The loss component is nothing but iron losses and magnetic losses, which is nothing but friction and windage losses. This is nothing but the constant. For calculating the iron loss, it is found by a product of weight into specific loss value, or the weight into loss per kgs. So we know this basic details. This iron loss is dependent on hysteresis and eddy current. These two things is reduces by the proper design of creating the cores and selecting the cores. So this is the constant. Then the next one is nothing but mechanical losses. For that area, the friction and windage, it's all depend on the maintenance, as well as in the designing aspect it will relate with the constants. So the particular content related to the output rating, so the friction and the windage losses percentage of output is defined by this table. So just go through these assumptions. With this concern, we have to apply in the formulas. So the losses component of no load current is nothing but IL is calculated as the loss current is calculated by total no load losses divided by 3 into voltage per phase. By this equation, we can calculate the IL value. That's all for the operating characteristics. Here the operating character is nothing but to determination of no load values. It is nothing but I naught. That I naught is calculated by calculating the two component. One is nothing but Im and the another one is nothing but IL. Im is nothing but magnetizing current. That magnetizing current is calculated by total mmf value. The total mmf value is calculated by summation of 5 mmf, mmf in the air gap, mmf in the rotor teeth, mmf in the stator teeth, mmf in the rotor core, mmf in the stator core. After finding all the core by clubbing, we can find the total mmf. By finding total mmf, we can find the magnetizing current. Then a loss component. For this loss component is nothing but a total no load losses is required as per 3 of voltage per phase. That's all for the peoples. After finding these two things, we can easily predict the operating characteristics of an induction machine.